Okay, so now we're going to look at what's called the sum and difference rule. So basically we're going to take the derivative of two functions or more, but basically we're just going to work with two for the proof. So if I take some function plus or minus, it works the same either way for adding or subtracting, of another function, then that's the same as just taking the derivative of the first function and then taking the derivative of the second function. Okay, but let's prove this before we go ahead and use it. So here's a proof. All right, so my function is going to be f of x equals u of x plus v of x. Okay, so the derivative is going to be the limit as h approaches 0 of f of x plus h minus f at x over h. So the limit is going to be, I'm going to plug x plus h into both of these, so that's going to be u of x plus h plus v of x plus h, minus, I'm going to plug x into both of those, so that's just going to give me u of x plus v of x all over h. Okay, so now that's going to give me the limit as h approaches 0. If I distribute out this negative, I'm going to get u of x plus h plus v of x plus h minus u of x minus v of x over h. So that's going to give me the limit as h approaches 0. I've got, now I'm just going to reorganize this. I'm going to put the u of x functions, the u functions first and then the v functions next. So I'm going to put u of x plus h minus u of x. So I'm just listing those first. I'm going to split them too. Plus, then I'm going to take v of x plus h minus v of x over h. Okay, so I'm going to distribute this limit out to both of them because we know our rules from limits that we can do that. So I'm going to take the limit of u of x plus h minus u of x over h plus the limit as h approaches 0 of v of x plus h minus v of x over h. Now this should look really familiar to you. This right here is the derivative of u of x. This right here is the derivative of v of x. That is what I needed to prove, is that I had to take the derivative of u and the derivative of v. So I start with this function, and the derivative is by taking each individual piece. All right, so let's put this into an example. Let's try an example. I can make up anything. F of x equals 3x squared plus 9x to the fourth. Okay, so the derivative, I'm going to use my constant multiple rule, but I'm going to just take the derivative of this piece. Is going to be 2 times 3, which is going to give me 6, x to the first power, plus 9 times 4 is going to give me 36, x to the third. And that is it. That is how you can take the derivative of functions.